Here's an application involving quadratic functions and their graphs. Let's examine this not with Desmos, but just by thinking about what the graph would look like by hand. And we'll be able to answer this without Desmos just by thinking about what we've learned previously about finding a vertex. A baseball is thrown by an astronaut on the moon. Its height in feet above the moon's surface t seconds after it's thrown is given by the function h of t equals negative 2.55 t squared plus 61.2 t plus 6. What is the maximum height reached by the ball, and when is it reached? Well, instead of graphing this in Desmos, let's just think about the general shape. This has an input variable of t squared, so that means it's a quadratic, and it has a parabola as its shape. Because it has a negative leading coefficient, that means it's a parabola opening down. So let's just kind of sketch that out. Now let's think about the scenario here in terms of the axes. So we have a parabola. The horizontal axis is going to be the input variable, which is t or time. The vertical axis will be the output variable or height. So what we have here is the height on the vertical, so that because this parabola is opening down, that highest point, or at the vertex, is going to be the highest point or the highest height that the ball reaches. So this is the highest point of the ball. So if I want to answer this question, I need to find the vertex because I want to find the maximum height. So we've learned how to find the vertex by hand. We don't need Desmos to find the vertex. We can do it one of two ways. We can complete the square, or we can use the formula for the vertex. Now, completing the square, sometimes people shy away from it with application problems because of the decimals that can be involved. But it's certainly possible to do completing the square. I'm going to go ahead and use what often is the quicker way when you're working with decimals, and that is to just use the formula. So our input variable is t, so I'm going to start by finding the input value for the vertex. So t is negative b over 2a with the formula. B is 61.2, so my numerator is negative 61.2. My denominator is 2 times a, which is negative 2.55. Remember to calculate the denominator before you divide. So negative 61.2 over negative 5.1. And then calculating that out, we get t is equal to 12. Comes out nicer than you may be expected. It doesn't always come out nice. You just have to look at what happens when you do the division with your numbers. Once we know t is 12, that is the x value, or the t value in this case, because our input variable is t, of the vertex. We need to find the output value, or the height. So remember, h of 12 is how you're going to do this. You're just going to put 12 in for t and calculate the output. So negative 2.55 times 12 squared plus 61.2 times 12 plus 6. Now this is an application, so of course you would have your calculator available. And calculating this in your calculator, h of 12 is equal to 373.2. If you do this all at once, the calculator will know to square before you multiply. If you do it bit by bit, don't forget that you must square before you multiply by negative 2.55. So there's our output value, 373.2, and that completes our vertex. So this vertex is located at this point. Now, let's interpret this. Remember, my first value here, 12, has to do with time in seconds. My second value here is the height, and it's the maximum height. So writing this out in words, we would have something to the effect of, and you can write this multiple ways, but the maximum height of the ball is 373.2 feet. And then we can put the time 12 seconds after it is thrown. Again, it doesn't matter which one you talk about first in the sentence. You could say 12 seconds after it is thrown, the ball reaches its maximum height of 373.2 feet. But you need to connect in the sentence both the input and the output of the vertex.